Welcome to my channel. Today we'll be looking at normalized and orthogonal system on Sturm-Liouville problems. Alright, so sometimes we might be asked when is a function said to be normalized and when is a function said to form an orthonormal system. So these two, they are two different things but they are similar. So let's look at their similarities. Let's look at what they mean. So first of all, a function phi of x is said to be normalized on the interval a comma b with respect to the weight function r of x if the integral from a to b of phi of x all squared with times r of x dx is equal to 1. So if that integral is equal to 1, we say that that function phi of x is normalized. Alright, so this is where it gets interesting. Look at b. An infinite set of functions phi of n, when you have a lot of functions, so that function is said to be an orthonormal system with respect to the weight function r of x on the interval a comma b if it is an orthogonal system. One, so two things, it must be an orthogonal system and every function of the system is normalized with respect to the weight function. So mathematically what it means is that that integral from a to b of phi of x of phi of n r of x dx will be equals to 0 when m will be equal to this integral will be equals to 0 when for m not equals to n. So that is the one that shows that it is orthogonal. So when m is different from n, when you have a distinct functions, it must be 0. Then when m is now equals to n, when m is equal to n, the function, that integral must give you 1. Equals to n, they are 0. When you show that it is equal to 0, then you've shown the orthogonal part. Then when m is equal to n, like when the function you pick, they are the same, and then with respect to the r of s, that integral gives you 1, we say that it is normalized. So as long as these two conditions are satisfied, then you've shown that the function is orthogonal. Just show that the function is normalized and it is orthogonal. You've shown that it forms an orthogonal system. So let's look at this example. Okay, so determine the orthogonal system of the aging function of this. This is also a Sturm-Liouville problem. So to solve this problem, we need to get the aging functions. So meaning we need to solve the Sturm-Liouville problem and get the aging function and use the aging function. It is those aging functions we show that they are orthogonal. So let's get started. So solution, we have for the first one. Okay, so yes, to solve it now, we consider case 3. Case 3 is when we have a non-trivial solution. So let's look at case 3, lambda greater than 0. So for lambda greater than 0, we can set our lambda to be equals to m squared, to be equals to k squared. So you have y prime plus k squared, then y equals 0. Solving the auxiliary equation, m squared plus k squared is equal to 0. M squared is equals to minus k squared. M squared is equals to the square root of that, which is plus or minus ki. So we've gotten the complex solutions. So because we have a complex solution, our general solution will be a cos kx plus b sine kx. So let's solve for the constant. So we use the boundary condition. So if you look at the boundary condition they give us, is x at 0 and x at 1. At those 2 points, y remains at 0. So you can say at s equals 0, y is 0. So you put 0 for y, then you get cos 0 plus sine 0. So cos 0 is 1, sine 0 is 0, so you just get a. So a is equal to 0. At s equals 1 and y equals 0, you get 0. A is already 0, so this part will give you 0. You only have b sine kx. So just like the way we solve Sturm-Liouville's problem, if b is not 0, so it means that sine ks will be the one that will be 0. And sine ks is 0. Oh, sorry. X is 1, so you have to put 1 here. So this is 1. So sine is 0 at n pi, so you put n pi here. So it means that k is equals to n pi. What is lambda? Lambda is equals to k squared. That was how we define our lambda. So that is n pi all squared. That is n squared pi squared. So that is your lambda. So what are the eigenfunctions? So the eigenfunctions are bn sine, it is a is 0, so it's b that is left. Kx, it was ks, so that is n pi of x. These are your eigenfunctions for n equals 1, 2, 3, all the way to infinity. So that is the eigenfunction. So we are asked to show that these eigenfunctions are orthonormal. So to show orthonormal, we need to show orthogonal. So first of all, we show that the functions are orthogonal. But there is a theorem that says that as long as these functions that we get is a solution to a Sturm-Liouville's problem, they are orthogonal. Okay, as long as this function is a solution to a Sturm-Liouville problem, so it is orthogonal. So this is what you can write. You can say since b1 sine n pi x is they form an orthogonal system, then this is at n equals 1 now, so this would be 1, this is 1, sorry, so it's just 1 pi nx, then the other one should be b2 sine 2 pi x, the other one is b3 sine 3 pi x. So these are infinite set of functions. They are infinite set of functions, infinite set of eigenfunctions. So let's SL represent Sturm-Liouville's. So we have to the Sturm-Liouville's problem that they give us. So so they are orthogonal system. And what does that mean? It means that this integral from 0 to 1 of 1, the weight function is 1, bn sine nx, then bm sine mx, this integral with respect to x is equal to 0. So that is what we are saying. So this is the m and n are not the same though. So that is what we are saying. So if you solve it, you still get 0. So we are saying as long as these are infinite set of eigenfunctions to a Sturm-Liouville's problem, this is always 0. So now that we've done this, the next thing to do is to show that they are orthonormal, they are normalized. So for you to do normalize, you just have to pick a function and use the definition of normalized and show that it is equal to 0. So we just say next we do normalized. Now for that function to be normalized, for this aging function to be normalized, we need the value of constant that will make that condition to be satisfied. That is, this integral from 0 to 1 now. The weight function is 1. How did I get 1? Let's go back to the question. So this is a Sturm-Liouville problem. So this is lambda y. The coefficient of this lambda y is your r. So the coefficient here is 1. So that is why your weight function is 1. So moving on, we have Bn and sine n pi or squared, times the weight function ds. So this is integral from 0 to 1. So this will be equals to 1 first. And this is equal to 1. So that is the definition. This is equal to 1. So we need this value of constant that will make this left hand side to be equal to 1. So I hope you understand. So now if you open that square, you get Bn squared sine square n pi ds equals to 1. So you can bring out this, then you get sine square n pi ds equals 1. So how do you integrate this? So integrating this directly is not something easy. So you also need a property from trig. So we know that cos 2x is equal to 1 minus 2 sine x. So then if you make sine square x sort of formula, you get 1 minus cos 2x over 2. Then what this means is that if here is x, like if the number here is x, if the value here is x, this is 2x. In what we are doing, what we have is n pi. I didn't add s, sorry, n pi x. There is x in it, so it is n pi x. So this now you multiply it by 2 on the other side, so you get 2n pi x all divided by 2. So this is what we are going to integrate. So integrating that, 0 to 1, 1 minus cos 2n pi x over 2 ds is equal to 1. Sorry, you can bring out your 2. 0 to 1, 1 minus cos 2n pi x dx equals to 1. So now we have x minus sine. Cos will give you sine, right? Yes, you get sine 2n pi x over 2n pi from 0 to 1. This is equal to 1. So bn squared over 2. So if you insert 1, you get 1 minus sine 2n. Okay, you can say 2 pi n, then divided by 2n pi. Then for the 0, just get 0 minus sine 0 over 2n pi. So which will eventually give you 0, but let's just write it down. So this one, I've told you before, whenever you have this is sine 2n pi. Whenever you have a constant times in pi, it is still 0. So this is 0 and everything there is still 0, equals to 1. So at the end of the day, we have 2b times 1 equals 1, 2bn. So if you use 2 to times this side, you get 2. So it means that your bn is equals to the square root of 2. So that is bn. So with that, it means that the normalized aging functions are y of n equals, we've gotten b is this now, then sine n pi x for n equals 1, 2, 3, 4, and like that. So with this, we've shown that the given problem is a normalized, forms orthonormal system. Thank you for watching. See you in the next video.